Given f of x equals x cubed minus 8, find A, the complete first degree factorization, part B, all the complex real and imaginary roots. Looks pretty easy. Let's see. Now, x cubed minus 8 looks very familiar. Part A, we're going to factor this x cubed minus 8 as x cubed minus 2 cubed with the formula a cubed minus b cubed equals parenthesis a minus b times parenthesis a squared plus ab plus b squared. Okay, using that, we get the start of our complete factorization. F of x equals x minus 2 times x squared plus 2x plus 4. Now, this is now factored over the real numbers, okay? And we want all the first degree factors. When I say that, there's no imaginary numbers that appears in the factorization. Okay, but we're not far enough down because we have a second degree factor in that parenthesis. We need first degree factors. So to figure out what to do with that second factor, we're going to have to use the quadratic formula. We can't factor it on our own. It's too hard. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So we have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 4 over 2 times 1. And that simplifies to negative 2 plus or minus the square root of 4 minus 16 over 2, which is negative 2 plus or minus the square root of negative 12 over 2. Let's factor that square root of negative 12. It's negative 2 plus or minus the square root of 4 times the square root of 3 times the square root of negative 1 all over 2. And that simplifies to negative 2 plus or minus 2 times the square root of 3. And then that I, we're multiplying, that I is on the outside, all over 2. Let's factor the top. You have to factor before you cancel. Don't forget that. Factor before you cancel, and then you can cancel a common factor of 2. And now we're left with negative 1 plus or minus the square root of 3 times I. Thus, our complete factorization, in other words, x minus the roots, we want to write this as a series of factors, x minus the roots. We know all the roots now. It is parenthesis x minus 2 times x minus bracket negative 1 plus the square root of 3i times x minus bracket negative 1 minus the square root of 3i. Okay, so one had the plus in the middle, the other had a minus in the middle. Now we're going to get rid of the inner brackets by distributing the negative sign just to clean it up. And we'll have f of x equals x minus 2 times x plus 1 minus the square root of 3 times I on the outside. Enclose your parenthesis. And then the last parenthesis is x plus 1 plus the square root of 3 times the I on the outside. And that's our linear complete factorization. Now for part B, we have to reconsider the form x minus c sub 1 times x minus c sub 2 times x minus c sub 3, where the c's are the roots. Well, we had that on the step above the box. So our roots are the numbers being subtracted: 2, negative 1 plus the square root of 3i, negative 1 minus the square root of 3i. And we're finished. Once you get it down to a complete factorization, it's very easy to see what the roots are.